I'm Dr. Aneela. I'm working as Assistant Professor in Department of Physics, B.V. Raju Institute of Technology, Narsapur. My course name is Applied Physics. Today I'm going to discuss on the topic of lasers. So outline of my presentation goes like this. So first I'll discuss about the importance of lasers. So the lasers are used in many different fields. So I'll explain major fields where do we use the lasers. And then I'll give you a brief introduction about the lasers. After that, the laser fundamentals. So there are three important parameters are there for lasers. So I'll explain those. After that, basic principles of lasers. So in lasers, the photons are interact within three ways. So those are absorption, spontaneous emission, and stimulated emission. So after that, I'll discuss about differences between spontaneous and stimulated emission. Then characteristics of laser light. So there are four important characteristics are present in lasers which will differentiate from the ordinary light. So and then finally I'll summarize today's class. So coming to the importance of lasers, the lasers are used in different applications so with these unique properties. So majorly the lasers are used in medical field, defense field and scientific and research field. So in medical field, the lasers are used for the eye surgeries, plastic surgeries and to remove the brain tumors and endoscopic studies and dental treatment and extraction. So in many fields, in these ways, the lasers are used in medical field. And then the second major field is defensive field. So lasers are used in most of the defensive applications. So majorly lasers are used here in guns to target the aims and rangefinders and laser sight, and these are also used as a target designators. And the lasers are also used in scientific and research field. So here the lasers are mostly used in spectroscopy. So here the lasers are used to identify the unknown molecular structure and to break the molecules. And here lasers are also used to separate the isotopic elements. And these are also used in photochemistry. So not only limited to these applications, the lasers are used in many different applications. So coming to the introduction of lasers, so as we all know that the entire universe is made up of energy and matter. Again, the energy is composed of three things: to the solids, liquids and gases. Again, these solids, liquids and gases are made up of atoms or molecules. The central part of the atom is positively charged nucleus, and the electrons are negatively charged particles. So the electrons are revolves around the nucleus in different orbits, like this. So each electron will have the different energy levels. So this is the positively charged nucleus, and this is electrons are revolves around this nucleus, and these are having different energy levels: E1, E2 and E3 and so on. Okay. So if you supply the same amount of energy to the lower energy state E1, so it absorbs that energy and goes to the higher energy state, so that it makes a transition from lower energy state to higher energy state. So like this. Okay. So these are all basic electronic transitions in case of atoms. So all these electronic transitions are very important in for light amplification in case of laser source. So coming to the basic definition of lasers, the laser is a device. It emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. So lasers works on the principle of stimulated emission of radiation. And the laser stands for, L stands for light, A stands for amplification, S stands for stimulated, E stands for emission of radiation. So it works on the principle of light amplification by stimulated emission of radiation. Okay. So during this process, so many electronic transitions are present. So in light amplification case of lasers. And This laser is a device, it produces a coherent beam of optical radiation by stimulating electronic, ionic or molecular transitions to high energy levels. So if we supply some amount of energy to the lower energy state, so it absorbs this energy and goes to the higher energy state, right? So at the higher energy state, the atoms cannot stay more time because the lifetime of the higher energy state is very short. So after completion of lifetime, the atom comes to the ground state. So by emitting some amount of energy, so that energy is called radiation. So while when they return to lower energy levels by stimulated emission, so they emit energy. Okay. So in this way, the basic process happens in case of lasers. So the first laser was demonstrated by Maimon in 1960. So next, coming to the laser fundamentals, there are three important parameters are present in case of lasers. So when compared to the ordinary light, so the light coming from the laser source is highly monochromatic in nature. So monochromatic means, mono means single, chromatic means color. So it exhibits a single color and single wavelength. So in case of ordinary light, so it is a combination of many colors and many wavelengths. And the second property is the light coming from the laser sources, it is highly directional in nature. So when compared to the ordinary light, means the laser light is emitted as a relatively narrow beam in a specific direction. But in case of ordinary light, the emitted light travel in many directions away from the source. And the third one is the laser light is highly coherent in nature. So which means that so the wavelength of the laser light it maintains the constant phase difference. But in case of ordinary light, so it will not maintain the constant phase difference and it can be a mixture of many wavelengths. So the laser light is highly coherent in nature. So if you compare the ordinary light and the laser light, so in case of ordinary light, so the light coming from this light it exhibits the many wavelengths and it is multi-directional and it is incoherent in nature. The laser light is highly coherent in nature, highly monochromatic and it is highly directional. So these are the main differences between the ordinary light and the laser light. So these three properties, the laser light makes a more hazardous than the ordinary light. And all these properties, the laser light can be used in different applications. Why? Because the laser light can deposit a lot of energy within a small area. So these are all the few fundamental properties present in the lasers, so which will differentiate from the ordinary light. So coming to the basic principles of lasers, there are three basic processes involved in lasers for amplification of light in case of lasers. So basically lasers, the photons are interacted in three ways with the atoms. So those are absorption of radiation or stimulated absorption. And the second one is spontaneous emission. Third one is stimulated emission. I will discuss one by one. The first process is stimulated absorption. So to understand this stimulated absorption process, so first let us consider an assembly of atoms. So that is represented by, assembly of atoms are represented by, for example, N0. So this N0 atoms are distributed into two energy levels, E1 and E2. E1 is the lowest energy level, E2 is the highest energy level. And this N0 atoms are distributed to energy levels E1 and E2. For E1, for lower energy level, the population is represented by N1. For the higher energy state, the population is represented by N2. So, on this process, I will explain with the energy level diagram. So, if we observe this is the lower energy state E1 and E2 is the higher energy state, excited state. So, initially, all the atoms are present in ground state. So, why? Because the ground state energy level is more stable than the high energy state. So, initially, the atoms are present in the ground state. So if you supply some amount of energy in the form of photon, so this ground state atoms absorbs this photon of energy and it goes to the higher energy state. So this is the case before absorption, the atoms are present in the ground state. If we supply some amount of energy in the form of photons, h nu photons. So this ground state atom absorbs this amount of energy and goes to, after absorption, the atoms are present in the high energy state. So whole of this process is called stimulated absorption. So here, so the atoms are not going directly from ground state to excited state. So we are giving some stimulus of energy, H nu. So that's why this is stimulated, and here absorption process is taking place. So this process is called stimulated absorption process. And the second process is spontaneous emission. So here, initially the atoms are present in the higher energy state. So that is E2 level. So for high energy state, the lifetime is very short, that is 10 power minus 8 seconds. Okay, so after completion of this lifetime, so the atoms comes to the ground state by emitting photon of energy H nu. So initially the atoms are present in the high energy state. Okay, so after completion of lifetime, so the lifetime is very short for high energy state, that is 10 power minus 8 seconds. So after completion of this lifetime, the atoms are spontaneously coming from high energy state to low energy state by emitting photon of energy H nu. So this process is called spontaneous emission. So here we are not giving any source, external source. So directly, automatically the atoms are coming from high energy state to lower energy state. So this process is called spontaneous emission. So here the atom decays from level 2 to level 1 through the emission of a photon with the energy H nu. So, and it is a completely random process. And the emitted photon will not maintain any specific time and any specific wavelength. So the process is completely a random process. So the emitted in spontaneous emission, so the emitted photon will have the some specific properties. The spontaneous emission is a random in character, and the emitted photon will not maintain the constant phase difference, and the radiation is incoherent and has a broad spectrum. And in this emission, no incident photon is required, no external source is required. So, and only single photon is emitted. And the energy of the emitted photon, that is which is equals to H nu, which is equals to the difference between two energy states E2 minus E1. So these are the few properties during this spontaneous emission. And the next process is stimulated emission process. So the atoms are present in the excited state E2. So the photon of energy will incident on the excited state atoms. So before completion of this lifetime. So this photon will help the atom sending from high energy state to lower energy state by emitting photons of energy H nu. One is incident photon and the other one is emitted photon. See here, so if the photon, initially in spontaneous process also the photons are present in the high energy state. So there we are not supplying any amount of energy. After completion of lifetime, the atoms are automatically coming from high energy state to lower energy state by emitting single photon of energy. But here the photon of energy will incident on the high energy state atom before completion of lifetime. And this photon of energy will not absorbed by this atom. So this photon helps the atom coming from high energy state to low energy state. So that's why two photons are coming out. One is incident photon, because here this photon is not absorbed by this high energy state atom. So this incident photon and the emitted photon. So here again these two photons will go and interact with the high energy state atoms. Again these two photons will be converted into 4. Again 4 photons will be converted into 8. So in this way the photons will get multiplied in case of stimulated emission of radiation. So and this process, the stimulated emission process, is directly involved for amplification of light in case of lasers. So this process is called stimulated emission. So here we are providing some stimulus of energy to the high energy state atoms, and here emission process is taking place. So 2 photons are emitted as a resultant. So the whole of this process is called stimulated emission process. So this is the before absorption and this is the after absorption. Okay, so in stimulated emission, the stimulated photons have three unique properties. So the emitted photons, in case of stimulated emission, it is in phase with the incident photon, and it has same wavelength as the incident photon, and the incident photon travels in same direction. The emitted photon will travel in same direction as incident photon. So this image shows what the spontaneous emission. So this process, in spontaneous emission process, a single photon is emitted. So this is image shows what the stimulated emission. So here in this process, that two photons are emitted. So these are the basic processes involved in case of lasers for light amplification. So among these three processes, the stimulated emission process is directly involves for amplification of light in case of lasers. Okay. So then there are some differences between the spontaneous and stimulated emission of radiation. So in case of spontaneous emission of radiation, so the emitted light, it is a polychromatic radiation, and it is a monochromatic radiation. So it is a combination of many wavelengths, so it exhibits a single wavelength. And the emitted photon has less intensity, it has high intensity, and it has less directionality and more angular spread during propagation, and it has high directionality and so less angular spread during propagation, and it easily exhibits the incoherent in nature, spatially and temporally incoherent radiation. It is spatially and temporally coherent in nature. And in this emission, the light is not amplified, so only single photon is emitted. So here in this emission, light is amplified. So here the photons will get multiplied, so that the 2 will be converted into 4, 4 will be converted into 8, 8 will be converted into 16. So that the photons will get multiplied, so the light amplification can be done through this process. Okay, so here in case of spontaneous emission of radiation, a single downward transition, the spontaneous emission results in the emission of one photon. Here in a single downward transition, stimulated emission results in the emission of two photons. So the example for the spontaneous emission of radiation is the light from the ordinary bulb and the light source from the LED light. And here in case of stimulated emission of radiation, example for this is the light from a laser source. So this process is postulated by Bohr, and this process is postulated by Einstein. So these are the major differences between spontaneous and stimulated emission of radiation. Then characteristics of laser light. The laser light has four important characteristics are present. So when compared to the ordinary light, so the most important characteristics of a laser beam are high monochromaticity, high degree of coherence, high directionality, and high brightness. So I'll discuss one by one. So these points I've already discussed in the starting. So I've discussed elaborately here. The monochromaticity is nothing but the laser light is monochromatic or very pure in color. So it means it exhibits a single color and single wavelength. And the bandwidth of the laser beam is narrow. So while in case of ordinary light, it spreads over a wide range of frequencies. So that is the main difference between the ordinary light and the laser light. And the laser beam is in single wavelength, so that is the line width of the laser beam is extremely narrow. And in case of ordinary light source, the wavelength spread is usually 1 in 10 power 6. But in case of lasers, the spread will be 1 in 10 power 15. It means that if the frequency of radiation is 10 power 15 Hz, and then the width of the line will be 1 Hz. So this is the main difference between the ordinary light and the laser light in terms of wavelength spread. So here if you observe this figure, so this is the light source exhibits the monochromatic light. So this is the example for the monochromatic light source, and this is for the conventional light source. So whenever the white light falls on the prism, so it appears many colors, different colors and different wavelengths. So this also shows the comparison for the wavelength spread in red wavelength and the blue wavelength. So here for red, the wavelength spread is more when compared to the blue light. So the next important property is directionality. The laser beam emits light only in one direction, and also the laser light can travel very long distances without spreading. So that's why with this property the laser communication is carried on between the earth and the moon. And the directionality of a laser beam is expressed generally in terms of divergence. The formula for the divergence is delta theta is equals to r1 minus r2 divided by d2 minus d1. Here r1 and r2 are the radii of laser beam, and d1 and d2 are the distances. Okay. So generally the divergence here tells that how rapidly the beam spreads when it is emitted from a laser. In general, for a typical small laser, the divergence for a laser beam is usually 1 milliradian. So in this way the laser light is highly directional in nature. So this is the source coming from ordinary bulb. So it is travels in different directions. It travels in many directions. The source coming from the laser, so it travels in single direction. Okay, the spreading is more here, and the spreading is less in case of laser light. And the third property is coherence. The laser light is highly coherent in nature when compared to the ordinary light. So coherence is nothing but also the emitted the photons will maintain the constant wave difference, and it maintain the same frequency, same wavelength, and same energy. Okay, so the laser beam is both spatially and temporally coherent. So if you see this image, so this source coming from the sunlight, so it exhibits the many colors and many wavelengths and many frequencies. So if you see this figure, the light source coming from the LED light, so it exhibits the single color but many wavelengths and many frequencies. So here this laser, the source coming from the laser source, so here it maintains the constant phase difference, and it exhibits the single color, it exhibits the single wavelength. So this is the main difference between the ordinary light, LED and laser source. So in this way the laser light exhibits the highly coherent in nature. After that, a high brightness or high intensity. The laser light has high intensity than the conventional light source. The laser beam is highly bright as compared to the conventional light because more light is concentrated in a small region. So more power is concentrated in a very small region. So that's why the laser light has high intensity than the other sources. And it is observed that the intensity of 1 milliwatt laser light is 10,000 times brighter than the light from the sun at the earth's surface. So this much difference will be there. And the number of photons coming out from a laser per second and per unit area is about 10 power 20 to 10 power 34. But in case of normal black body radiation at 1000 degree Kelvin, it is 10 power 16. Okay, so from laser source, it is more than the normal source. And the laser light is coherent, and so at a time many photons are in phase and they superimpose to produce a wave of larger amplitude. So as we know that the intensity is directly proportional to the square of the amplitude. So and hence the intensity of the resultant laser beam is very high. So in this way the light coming from the laser source is high intense than the other conventional light sources. So these are the four important characteristics. So those are the laser light is highly coherent in nature, high monochromaticity. It exhibits the high monochromaticity, and it has high brightness or high intensity and high directionality. So with this, I'll summarize today's class. So I've discussed importance of lasers, and lasers are used in different applications. And then I've given the brief introduction about the lasers, and then basic processes involved in case of lasers. So among those processes, stimulated emission of radiation is directly involved for amplification of light in case of lasers. And then fundamental properties and the fundamental characteristics of lasers, which will differentiate from the ordinary light. So with this, I'll conclude this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.